We begin our class with section 2.1 titled Logical Form and Logical Equivalences. Here's a quick outline of what we will be discussing in this section. Leibniz conceived the idea of using symbols to mechanize the process of deductive reasoning in much the same way that algebraic notation had mechanized the process of reasoning about numbers and their relationships. In other terms, a lot of the symbols and the ideas that we're going to be learning in this section are due to Leibniz. So we start by introducing the concept of an argument. What is an argument? The definition says, an argument is a sequence of statements aimed at demonstrating the truth of an assertion. An assertion is basically an idea or a statement. The assertion at the end of the sequence is called the conclusion, and the preceding statements are called premises. So think of an argument like an English essay, where you describe using mathematics or other concepts how something could be true or false. The word statement itself, sometimes it could be substituted with the word proposition, is a sentence that is true or false, but not both at the same time. So here are some examples of statements. Saying that 2 plus 2 is equal to 4 is an example of a statement. Somebody could verify this. It could be either true or it could be false. There is no way it could be both true and false at the same time. For instance, 2 plus 5 is 8. That is an example of a statement because technically it is false. Finally, the moon is made out of blue cheese. That is an example of a statement because we can verify that it is not. This is an example of a statement that is false. Here are some examples of statements, or actually non-statements. X plus y is greater than 0. That could be true or false depending on the values of x and y. Saying something like he's a college student, we don't know who he is, so it could potentially be true or false depending on the person we're speaking about. So that is an example of a non-statement. And finally, x squared less than 25 is an example of a non-statement because again, we don't know what x is. Depending on the value of x, if x is 1 for example, then the statement would be true. If x is 10 for instance, then 10 squared will be 100, which is not less than 25, so now all of a sudden the inequality becomes false. So again, that is an example of something that is not a statement. For some notation, throughout this chapter, we're going to be referring to statements with small letters. So for instance, the sentence 2 plus 5 is 8 could be called by the small letter p, or often the letter q. The tilde symbol means not. In other terms, it's the negation of the statement p. So saying that if p is 2 plus 5 equals to 8, then tilde p would be, it is not the case that 2 plus 5 is 8. Or more simply, 2 plus 5 is not 8. We will also use the wedge symbol. The wedge symbol is going to be referring to the word and. So if you want to replace the word and with a symbol, you're going to use the wedge. So writing p wedge q means p and q. This is also known as the conjunction of p and q. So when you hear the word conjunction, you should be thinking of the word and. And finally, the V symbol. That will be the word or. So writing P VQ means the same thing as P or Q. So we have two statements with an or in the middle. Or statements can be called also disjunctions. So when I say the disjunction of P and Q, I'm talking about P or Q. Just like the plus, minus, multiplication, and divisions have their order of operations in algebra, tilde, wedge, and v have their order of operations as well. In logic, tilde has the highest priority. So if there's tilde and a wedge and a v, tilde has to be done first. Also, the wedge symbol and the or symbol, the v symbol, are both of the same equal priority. So when they show up together, you got to be careful and put parentheses, otherwise things can be misunderstood. Now there are other ways of saying the word and without using the word and here are a couple of them. The words but and neither nor are examples of and or conjunction statements. So saying P but Q should be understood as P and Q. Even though it has a negative connotation, it doesn't really matter. We just use the wedge symbol. Similarly, saying P, neither P nor Q, should be understood as not P and not Q. So negate the P, negate the Q, and put an and symbol in the middle. So some examples. Suppose that the letter H represents the statement, it is hot, and the letter S represents the statement, it is sunny. Can you translate to symbols, it is not hot, but it is sunny? So take a minute to pause the video here and see if you can figure that out. Also, can you translate into symbols, it is neither hot nor sunny? Hopefully you took some time to try this out on your own, but because the symbol H is for it is hot and the symbol S is for it is sunny, then the first example would translate to the following: not H and S. It is not hot and it is sunny. Remember, the word but can be replaced with the and symbol. Now the second example says it is neither hot nor sunny. So there's an example of a neither nor. Since H stands for it is hot and S stands for it is sunny, then in this example we end up with not H and not S. This can be further simplified to not H or S, but we need something called De Morgan's law in order to be able to make that simplification. And for now, we don't know De Morgan's law, so you're not responsible for simplifying the expression at this point in time. Let's try this out one more time. Take a minute to pause the video and see if you can answer the following two questions. Okay, so in this case, the letter P represents the inequality 0 is less than x. The letter Q represents the inequality x is less than 3. And finally, the letter R represents x is equal to 3. And notice how we're using small letters because these are all statements. So how would I translate the following, x less than or equal to 3? Well, the key is how we said the inequality. We said x is less than or equal to 3. So therefore, in symbols, it would be Q, V, R. Similarly, saying that 0 less than x less than or equal to 3 can be translated into the following. First of all, we have to start off by breaking the inequality down into two inequalities. Since it is a and statement, we're going to need to put an and in the middle. And from the previous part, we know that x less than or equal to 3 translates to Q or R. So finally, the compound inequality becomes P and Q or R, and parentheses around the Q and the R.